Hey, everybody, this is Preston Malm, and this lesson will be on, Algebra 2 lesson will be on solving exponential and log equations. Let's begin. All right, so solve this guy. 4 to the x equals 1 half to the x minus 3. Okay, if you remember from the last lesson, those different bases, actually 2 lessons ago, the different bases, 4 is a power of 2 and 1 half is a power of 2. So rewrite them as powers of 2. 1 half is the same as 2 to the negative 1. Okay, and then powers raised to powers, you multiply those, and then since I have 2 to a power on the left and 2 to a different power on the right, you can set those powers equal to each other and get x equals 1. All right, let's try another. Okay, same thing. These are both powers of 3's. 9 is 3 squared, 27 is 3 cubed, and again, powers to powers, you multiply those. All right, so then set the powers equal to each other now because you have 3 to a power on the left, 3 to another power on the right, and you get x equals 3. All right, same thing here. These are both powers of 10's, 10 squared and 10 cubed. Okay, powers to powers, you multiply, and then now we have 10 to a power, 10 to a different power. Now the powers equal to each other, and you end up getting x equals negative 4/5. Okay, number 4. Okay, these ones don't have the same bases, you guys. So what you're going to do here to get that exponent, and when you have a variable that's in the exponent, you guys, this is the rule. When the variable's in the exponent, you must log both sides. And since this is 4 to the x, I'm going to log base 4 to both sides because it's 4 is the base number and x is the exponent. Again, when the variable's in the exponent, you have to log base 4 of both sides. Okay, so here we go. So log base 4 of x equals log base 4 of 11. Okay, now this is my blah blah rule. If these numbers match up, it equals whatever that exponent is. So the left-hand side now is just x. So x equals log base 4 of 11. All right, and then to get your calculator response on this, you change your base formula. Whoops, there's supposed to be a fraction bar right there. Let me go ahead and put that baby in right there. So log base 4 over log base, log base 4 of 11 is log base 11 over log base 4, and these are now base 10s because there's no bases with them, and I have base 10 in my calculator, so it's going to be log of 11, punch in your calculator, log of 11, and then hit divided by log of 4, and you should get 1.73. So depending on what kind of mood I'm in or what the teacher is looking for, your teacher is looking for, they might want this one. Sometimes it's called a calculator ready answer, or they might want to have the decimal answer on that. Okay. All right, let's try another one. Okay, so log base 5 of 4x minus 5 equals log base 5 of x plus 3. Here, you just set the quantities equal to each other because it's, you got the same logs on both sides. So then this is an algebra 1 question now, you guys. So here I subtracted x on both sides, and then I added 5 to both sides, so you get 3x equals 8, so x equals 8/3. All right. Okay, this one here, remember the definition of log. This base over here to this power over here, 4 to the third equals this stuff, 5x minus 1. So here it is, 4 to the third equals 5x minus 1. 4 to the third is 64, then you plus 1 to both sides, you get 65, and 5 goes into 65 13 times. Okay, here, remember when we have a plus sign separating two different logarithms, I can combine them as one logarithm by multiplying those two together. Okay, and there's no base here, so it's understood to be base 10. So I'm going to go ahead and insert base 10 right there. So this becomes one logarithm. If it's a plus, it becomes one logarithm with the multiply sign. If it was a minus, then I would do division. It would be this one over this one. But this one's a multiply because it's a plus. All right, so now I'm going to go this base here to this power over here is going to equal this product right here. And I'm going to go ahead and distribute the 2x through the parentheses right there. All right, so I get that mess right there. 10 to the second equals 2x squared minus 10x, or 100 equals 2x squared minus 10x. Okay, those are all even numbers, so I can divide both sides by 2. I like smaller numbers when I'm solving quadratics. Quadratics have to equal 0, so I subtracted 50 from both sides. And then factors of negative 50 are negative 10 times positive 5. So you get x equals 10 or x equals negative 5. All right, I didn't say this in my first video when I was talking about the definition of logs. You can't log negative numbers. That's just a rule. You can't log negative numbers. So I'm going to cross out the 5, and your answer is x equals 10 only. All right, let's try a couple more, you guys. So here we have 3 times e to the x equals 3. Going to divide both sides by 3. You have e to the x equals 1. Remember, anything to the 0 equals 1, so x must be 0. Okay, anything to the 0 equals 1. All right, here's another one. Okay, 10 to the 2x minus 1 plus 4 equals 22. Okay, I'm going to subtract 4 on both sides and get 18. Now I'm going to log both sides because there's nothing in common with 10 and 18, you guys. So you can't even divide by 2 because this 10 has a power on it and this 18 doesn't have a power. I can't divide both sides by 2 right here. That's not, you can't do it because this doesn't have the same power as the other side over there. Okay, so what I'm going to do is log both sides, log base 10 of both sides. All right, don't forget it's base 10. Okay, so base 10, if these numbers match up, my blah blah rule happens. 2x minus 1 is what this side equals. And then I just punched in the calculator, log of 18. That's all it is, punched in log of 18 because it's in base 10. And I get 1.255. Okay, I'm going to plus 1 to both sides now and get 2x equals 2.255. And so x equals, divided by 2, 1.1275. Alrighty, so depending on what kind of mood your teacher is in or what class you're in, these are the assignments I would assign. So I flip-flop every year. Sometimes I do workbook, sometimes I do textbook. So right now I'm doing the workbook, but probably next year I'll probably do the textbook. So whatever you guys are doing, that's going to be your assignment.